Okay, Avalee and Ethan. Avalee and Ethan. All right, so we're skipping 11.5, and this is section 11.6, which is talking about volume. 11.6 and 11.7 I want to get done today and Monday. That way it's fresh in you guys in the juniors' brains for ACT on Wednesday, because we don't have school on Tuesday. Do you guys know that we don't have school on Tuesday? Track meet. Okay. So this is homework for section 11.5, 11.5, 11.6, 11.6, okay? Those problems, and I'm going to go back to this sheet. Do you guys have this one? Surface area and volume. Okay, surface area was this line right here. Volume is this one. Volume looks a whole lot easier, and I think it is, anyway. I don't know why they separated volume into two sections, but whatever, okay? Volume of a prism. Now, not just a rectangular prism, but it could be a triangular prism, like the bases are triangles going like this, right? One of those. You know what I'm talking about? Something like that, right? Triangular prism, that's the same thing, is capital B times H, okay? How do you find capital B, by the way? Or what is capital B? The area of the base. So if we're talking a rectangular prism, the area of the base would be base, or like length times width, right? So a lot of times a rectangular prism is length times width times height. Okay, have you guys heard that before? Length times width times height, okay? But it's capital B times H. So if you're dealing with a triangular prism, you just find the area of the base and then times the height. It's like filling it with water, right? I fill in the base first, and then I fill it with water up to the height, okay? Area of the base times the height. Now, fancy business that we have going on with volume in comparison to a prism and a pyramid. They have the same equation, except a pyramid is a third. A pyramid is a third of a prism. Did you know that? Like if I would connect it over here and connect it over here, it would be a whole prism, right? Whatever. It's like a third of it, okay? All right, cylinder is pi r squared h. Now, here's how this breaks down. It's the same as a prism. Same idea that we fill in the base and then we multiply by the height, right? We're filling it with water, so we fill in the base. The base of a cylinder is a circle, and a circle is pi r squared. Right? So we do pi r squared times the height. You're doing the area of the base times the height. So this literally is the same formula, capital BH. It's just that your area of your base is pi r squared, right? So same thing. Cone, exactly the same as cylinder, except a third. How fancy, right? Same thing. So like a third, if I would continue it on, those are my other three pieces, he would be a perfect cylinder. So cone is a third of a cylinder, pyramid is a third of a prism. Got it? And then a sphere is 4/3 pi radius cubed. It's gross. This is the only one that the formula for volume is grosser than the surface area. Why is it like that? I could get into that, but it's going to take me a long time to explain it to you. 4/3 pi radius cubed. Whatever.
You need 3 circles to make 4.
I don't know. That's just the ratio that they have come up with. I don't know. Over time, they've...
outer shell.
You need 3 circles to make 4 other circles.
So take away
Yeah.
part of that
Yeah.
leftover circle.
Quit, yeah.
I don't know. Whatever. Okay. So there's that. So make sure you hold on to this guy, and then we'll go through and do some problems. Here we go. All right. Keep in mind that when we are finding volume, at this very top, I like this little picture that they have. When you're finding volume, you are literally finding how many cubes will fit inside of a figure, right? Okay? So like this one is like a 2 by 1, 2, 3, 4, 5, 6, 2 by 6 by 4, right? So how many cubes are there total?
12 times 48.
48. There are 48 cubes right here because there's 2 this way, 6 this way, 4 this way. Multiply all those together. That's the area of the base times the height, or length times width times height. There are 48 cubes there. That's essentially what you're finding when you're doing this. This just so happens to be a rectangular prism. Okay? But that's essentially what you're finding in all of the things is the length, width, height. Okay. Let's go to, I'm going to skip this guy. Let's go to the check one. And we want to find the volume of this check guy. Okay? Can we do that? Volume of the check. What shape is this?
It's a prism.
It's a prism, right? This is a triangular prism. Shh. You boys. Triangular prism. Okay, volume of a prism is capital B times H. That is all. All right, we need to find, what is the base? Which ones are the bases?
The right triangle.
The triangles, yeah. So I need this guy and this guy. All right, so I need to find the area of one of those guys. I'm gonna rewrite this triangle over here. Boys, stop. 9 is this bottom. What else do I know about that triangle? Shh.
It's 15.
15 is the slant, right? What's this guy?
This thing.
Is it a 3, 4, 5?
Oh, yes.
Yeah, this guy's 3, this guy's 5, this guy would be 4, but it's actually 12, okay? So 9 and 12 are my base and height. How do I find the area of this circle, or this
That's a triangle.
triangle? 1/2 base times height, so 1/2 of 9 times 12. I know that half of 12 is 6, and 6 times 9 is
54.
54 is the base, okay? Then what's the height?
10.
10, right? It's laying like on its side, okay? So what's the volume? 540, what?
Feet cubed.
Feet cubed. Did you notice I did all of that? You did all of that without a calculator. Yes? Try your very best to do as much as you can without a calculator. So that is a prism, okay? All right, that is a triangular prism. The bases are the front and the back in that case, okay? Good? All right, next. Volume of an oblique prism. What the heck?
What is it?
The volume of an oblique prism. Oh man, the bases are what? What is this shape called, by the way? Some of you guys just
Pentagon.
No.
but One,
It's a
Oh, it's 4.
trapezoidal prism.
I thought there were
How
4.
weird of a word. It's a trapezoidal prism. The bases are trapezoids. Okay, so again, it's a prism, so volume equals capital BH, but we have to find the area of the base, okay? The base is a trapezoid, so I'm just gonna draw a better picture of this. Here's my trapezoid. The top is 2,
You know everything about training.
the bottom is 4, and what's 5?
The straight edge.
5 is this side right here? Oh crap. 5 is not the height of that prism, or of that trapezoid. We gotta do this one right here. Ugh.
That one is.
Okay, so what's this length right here?
1.
1. So we gotta figure out what that guy is, right? You see how that's 1? Because this is 2. All right, so I've got 1 squared plus, let's call this b. B squared equals 5 squared, yeah?
It's a square.
All right, 1 squared is 1, b squared, 25, subtract the 1, I got b squared equals 24, and the square root of 24, whatever that is.
Oh, yeah.
What's the square root of 24? I don't know. That you have to use.
4.82. I'm guessing. 4.82.
I'm gonna go 4.9.
4.89.
4.89, we'll go 4.9. 4.9 is the height. Okay, so again, we're doing a trapezoid. How do I find the area of a trapezoid? How do I find the area of anything?
You take the triangles and.
Base times height,
Yep.
right?
That's fine.
Except a trapezoid has 2 bases, 2 and 4. Which base do I use? 3, I average them together. So 3 times the height is 4.9. 3 times 4.9 is that area. That is 12 plus 2.7, 14.7. Check me.
3 times 4.9 is 14.
14.7. Okay, so that's the area of the base. The base is the trapezoid. So capital B is 14.7. Okay, what's the height?
8.
8 is the height. And then we're done.
117.6.
117.6, that's centimeters. Centimeters what? Cubed. Did we do cubed on the last one? I think
Yeah,
so.
we did.
Okay, so that one was a little tricky just in the fact that we got some trapezoid shapes going on. Okay? But totally manageable. Just dissect it and do all the steps. Is that what they got? Okay, we don't care. They don't say. Okay, 117.6. Good deal.
Cool.
Yeah. All right, example 3. Volume of a prism using algebraic expressions. This is disgusting. Okay. Gustavo wants to calculate the volume of juice in his juice box in cubic inches. Find the volume of the juice box in terms of x. How the heck do we do this?
X times 4.9.
X times 4x times 4x plus 3. Holy crap, how do we do that?
Maybe
Distribute
Gustavo
the
does
X.
too.
Now, I can't do this, right? All I do is take x times 4x. So that's 4x squared. Now I can take the 4x squared and I can distribute the 4x squared through, right? Okay, what does that make? 16x cubed plus 12x squared. That is the volume in terms of x. Right here, 16x cubed plus 12x squared. Okay? Find the volume of the juice box if x is 2. Now what? Just plug in 2. 16 times 2 to the third plus 12 times 2 to the second. 2 to the third is 8, and 16 times 8 is 80 plus 48, which is 128. Plus, this is 448, and I get 176. And that is in something. It does not say what my, in cubic inches. Okay, so inches cubed. Perfect. Okay, good? All right, there you go. Oh, wait, pyramid. I don't want to do pyramid. Let's go to example 5. Find the volume of the pyramid in terms of blah, blah, blah. I don't want to do that. I don't want to do that. Let's do example 6, last one. Example 6, and then we'll be done. Oh, maybe example 7. We'll do 6 and 7, and then we'll be done. Okay, this is a composite figure, and we're finding volume. So we have 2 shapes going on here, right? So we got to do like double the work-ish. All right. What 2 shapes do we have?
Rectangular pyramid and a rectangle.
We have a prism, which is the bottom, and a pyramid, which is the top. Okay.
But isn't it a square since it's 6 by 6? Like it's a cube?
6 by
Yes, it's a square pyramid. Yes, correct. Yes, yes.
Oh, I guess.
The bottom wouldn't be a cube because this is 3 instead of 6. But yeah. Okay, so prism is capital BH and pyramid is 1/3 capital BH, right? Okay, so let's find the area of the prism first. Okay, prism is area of the base times the height. What's the area of the base going to be? The bottom. 36. So we've got 36 times the height, which is 3. And that is 90 plus 18, which is 108. Perfect. Did you do that in your head? Okay, that is the prism, 108 inches cubed. Okay, now my pyramid should have the same base. Capital B is still going to be 36, but this guy's height is not 3.
6.
And this guy's height is not 5 either. I want to do height here, okay? So I have to look at this as a triangle. 5 is this side. Okay, what's this little bottom side?
3.
3, right? Because it's half of 6, right? So the height is 4, actually. All right, I can do this in my head. Don't get a calculator. I can do this in my head. What's 1/3 of 36?
12.
12. And what's 12 times 4?
48.
48. That's the pyramid, inches cubed. I want to know how many inches cubed the whole thing is. Add them up. 156 inches cubed, I think. Yep. Okay, that is a composite figure, so you're just putting the 2 together. Got it? All right, last one right here. We have what going on here? The Washington Monument.
Brian, just
It's not the actual Washington Monument because these are in inches, so it's like a scale model. We have a chocolatier creating a replica of the Washington Monument. All right, so we want to know dimensions of this. What 2 shapes?
A prism and a pyramid.
Same thing again, pyramid and a prism. Okay, let's do the prism first. Capital BH, 1/3 capital BH. Okay, the prism.
What is that?
Capital B. This is a 6.5 by 6.5 by 6.5 by 6.5. So to find capital B, I take 6.5 times 6.5.
Oh, that one's easy.
That is, I don't know, something.
That's 42.25.
And then times
42.25. And then times what's the height?
36.
36. Okay, so the prism is how big? This I can't do in my head.
1521.
1521.
Yeah, I got that.
Okay, and that's inches cubed. That's the bottom. Okay, now the top. We're talking a pyramid.
6.5.
Okay, so it's gonna have the same base. So 1/3 times 6.5 times 6.5 is 42.25. Okay, but is his height 6.5?
Yes.
Yes. right? Height down the middle is 6.5, so we just gotta get away with that. And a third times 42.25 times 6.5, what does that come out to be? An icky number? Probably.
Graham, go ahead.
Raymond, can you get
42.25 times 6.5 divided by 3.
91.5.
91.5, okay, and that's in inches cubed. And now we have to add those two together. So this guy plus that guy is 16,
16, 12.
12.5 inches cubed. Perfect. There you go. That's how many cubic inches of chocolate. I would love that many cubic inches of chocolate.
I don't know.
Unless it's hollow on the inside. Have you seen like chocolate makers do
That'd be
like cool
surface
things?
area then, though. That wouldn't be square.
Probably selling
That
it.
wouldn't be cubed inches.
Good.
That'd be square inches, wouldn't it be? Like surface area.
Kind of.
Right, if it was hollow on the inside. But then you'd also have to take into consideration how thick the wall is. So what you would have to do,
And if it has the like. Yep.
yep, what you would have to do is you would take the outside, right? And then if it was hollow on the inside, you'd have to literally do the same thing again with the dimensions of the hollow inside and subtract the two volumes. Does that make sense? To figure out the cubic inches
Oh, that
of
makes sense.
chocolate. Mhm. Now, they probably, honestly, like, I'm not even making this up. They might actually do some of these calculations, but they would do it in cubic centimeters because a cubic centimeter is the same thing as a mil, correct?
A mill?
A milliliter? A milliliter is the same thing as a cubic centimeter. So if we had this in terms of cubic centimeter, I would need to know, I would have how many milliliters of chocolate liquid I would need to make this thing, right? True? Like they could actually do these calculations.
I feel like it'd be easier.
Right,
It'd be easier to
right.
just
So
get-
this calculation, what we just did was assuming that it was solid chocolate. Yes.
It'd be easy
Right.
to just get like a big, like, just a rectangular prism of chocolate and then carve it, than taking hollow
Or a
pieces and
mold.
then, or a mold.
Right.
Mold.
Yeah. But
Or you
so a
make
lot
the
of times what they'll
individual
do,
pieces
and then you weld them together, right? So a lot of times what they'll do is if like let's say they had a rectangular prism or whatever, they would fill it with chocolate, let it sit for a minute, and then pour it out. Does that make sense? So like the outside would be filled, like, and then it would be a certain thickness, whatever. You need to watch them make chocolate figurines and stuff. It's pretty like, it's very therapeutic watching all of that come together. It's kind of cool. So anyway, okay, that's it. This is homework. Okay.